Hello geometry students. In this video I'm going to take you through some flowchart proofs, and then you're going to try some flowchart proofs on your own. So just a quick reminder about flowchart proofs. They're different. They're the same kind of logic that we use in a two-column proof. The only difference is the structure. So instead of having a column for statements and a column for reasons, we instead use boxes and arrows so that you can kind of see the flow of logic a little bit better. Some students really like flowchart proofs over two-column proofs for that reason, that you can see that flow of logic better. So what we do instead of having a column for statements and a column for reasons is we put the statements inside the box, and then we'll always write the reason right below the box. All right, so let's get started with this first one. So in the first, we're given a couple of segments are congruent, and that triangle PSR, this triangle is an isosceles triangle with vertex angle at S. So what we're going to prove is that triangle PQS, I'm going to highlight that triangle. Let me make it yellow. So this triangle PQS, we're going to prove that it is congruent to triangle RQS, which would be this blue one. Okay, sorry for colored outside the lines, but I think you get the point. Okay, so let's start with some given information. Well, first of all, we're given that segment PQ is congruent to segment QR. So anything that's given, you want to mark in the diagram. Okay. Also, since that white triangle PSR is isosceles, we're going to be able to use the fact that an isosceles triangle has at least two congruent sides. So we're given a pair of congruent sides. The isosceles triangle are going to give us a second pair of congruent sides, and then the fact that segment QS is congruent to itself will give us a third pair of congruent sides. So the two yellow triangles, the yellow and the blue triangle are going to be congruent by side, side, side. So let's start with our first piece of given information, and that is that segment PQ is congruent to segment QR. All right. And remember, you put the statement in the box, and then right below the box you put the reason. So this reason is given. Given means that we're assuming that to be true. Okay. And then how about in that second box, let's put that second piece of given information, that triangle PSR is, oh, it's not going to quite fit, is okay, why am I having a brain cramp? Isosceles, there we go, I couldn't spell it. Isosceles, that's our other piece of given information, okay? So when it comes to keeping track of what parts are congruent, I like to put just a little letter just to remind me. I'm going to put an S right here that I already have one pair of parts congruent between the yellow triangle and the blue triangle. So let's see what else we can come up with. Well, let's use the fact that we have an isosceles triangle. We know from an isosceles triangle that we have a pair of congruent sides. So I can say that this segment PS is congruent to segment RS, okay? So I'm going to say PS is congruent to RS. Now that flows right from the fact that we assume that the white triangle is isosceles. So I can say that those two sides are congruent because that's what the definition of isosceles triangle would say. It would say triangle is isosceles if and only if it has at least two sides congruent. Okay, so I'm going to put another S. So I'm 2/3 of the way to getting the yellow triangle congruent to the blue triangle. The third part is going to be this side that the two triangles share, that segment QS. So I can say that segment QS is congruent to itself, and the reason is the reflexive property of congruence that says every segment is congruent to itself. So that gives me a third pair of sides. So now that I can see that I have 1, 2, 3 pairs of sides congruent, so that's enough to get congruent. The triangle's congruent. So I'm going to say that triangle PQS, the yellow one, is congruent to triangle RQS, the blue one, and the reason is going to be side, side, side. And before we go on to the next proof, I got to fix a couple things. First of all, I spelled isosceles wrong. How embarrassing. It's ISOSCELES, and then I also forgot to put a triangle right there. Okay, a couple details I wanted to fix. Now let's take a look at our second flowchart proof. Okay, in our second flowchart proof, notice this time we're given some information. We're given some parallel segments and a pair of congruent angles, but look at our proof statement this time. This time our proof statement is we're going to prove that a couple of segments are congruent. Now the way we will do that is we will get two triangles congruent and show that segment AB and segment CD are corresponding parts of congruent triangles. So after we get the triangles congruent, then we'll say that these two segments are congruent by CPCTC. So let's examine our given information. Well, first of all, we're given that segment BC is parallel to segment AD. Remember, we symbolize that by putting arrows on the lines. That's how we indicate lines are parallel. But I'm going to do one other thing. I'm going to highlight those segments in yellow. Okay, so we're going to assume that the yellow segments are parallel. We're also given this information that angle A, oops, that's not what I meant to do. Hold on. I have to use a pen and not a highlighter. Okay, angle, let's see, angle A is congruent to angle C. Okay, we're given that. And then what we're going to prove is we're going to prove that segment AB, that's this segment, is parallel to segment CD. So we're going to assume that the yellow segments are congruent, and we're going to prove that the blue segments are congruent. Okay? Alrighty, and the way we'll do that, oh, excuse me, I said that. Let me state that again. We're going to assume that the yellow segments are parallel. We're going to prove that the blue segments are congruent. Okay. So the way we're going to do this is by getting some triangles congruent. So let's see if we can figure out a way that we could get the two triangles congruent. So the two triangles I'm talking about, let me get a highlighter again. And I'm going to shade one of the triangles. I'm going to make this one green. So let's see if we can get the green triangle congruent to the white triangle. Okay. Well, we already have one pair of angles congruent, so that's good. Also, notice that the two triangles share a side, so that's good. The other thing that's going to help us are these parallel lines, and then this segment BD is a transversal. Let me see if I have another color. I guess I could use red. Let me highlight this segment. Oops, that's not a highlighter. Just a second. Get the right button. Okay, there we go. That segment, let's think of that segment BD as a transversal. So when we have parallel lines cut by a transversal, remember that's going to give us a pair of alternate interior angles that are congruent. So I think we're going to get plenty of parts to get the green triangle congruent to the white triangle. So let's start with our first piece of given information. And remember, you can use all of the given information together, but sometimes I like to just take one piece at a time. So I'm going to start with my parallel segments. Now, notice that information is given. Now, what would flow from that? If these yellow segments are parallel, how's that going to help us get the green triangle congruent to the white triangle? Well, we're going to use this transversal. Okay, when parallel lines are cut by a transversal, remember, alternate interior angles, angle 1 and angle 2, are on alternating sides of the red transversal and on the interior of the two parallel lines. So when parallel lines are cut by a transversal, alternate interior angles are congruent. So what flows from the fact that I have parallel lines? The fact that we have angle 1 congruent to angle 2. And here's how we'll justify that. Parallel lines cut by a transversal implies that alternate interior angles are congruent. Okay, so let's put an A there. We're 1/3 of the way of getting the green triangle congruent to the white triangle. Now let's go use that second piece of given information, that angle A is congruent to angle C. Okay, that was given to us. All right, we've already marked it on. Oh, you know what? Let's go back. And since we have angle 1, since we've proven angle 1 congruent to angle 2, let's go ahead and mark that. Okay, we've already marked that angle A is congruent to angle C, so that gives us a second pair of angles congruent. Okay, the last thing we're going to do is look at the fact that the two triangles share a side, and that segment is congruent to itself. So I'm going to put a tick mark on BD, and then I'm going to state that segment BD is congruent to itself. Okay, and we'll justify that with the reflexive property of congruence. Okay, And so that gives me a pair of sides congruent. So now I see that I have 2 angles and 1 side. That's enough to guarantee that 2 triangles are congruent. But now we have to be careful and look at the diagram, because our reason could be either angle side angle or angle angle side, depending on whether the side is the included side or not. So if you look at just one triangle, look at just the green triangle, okay? This segment would not be the included side, because I don't see, in the green triangle, I only see arcs at one end and not at the other end. This actually would be the included side, right? Because if this were the side marked congruent, notice we have arcs on either end. So it's the one that's between the 2 angles. It's the included side. So that means this is a non-included side. Okay, so our reason is going to be angle, angle, side. So notice that these 3, we've got an angle and a side. So they all point to this box where we can conclude that triangle, I'm going to call the green one ABD, okay, is going to be congruent to triangle. Now, if I call the green one ABD, notice I have 1 arc, no arc, 2 arcs. Then when I name the white one, I need to call it CDB, because that's 1 arc, no arc, 2 arcs. So triangle CDB, and the reason is because angle, angle, side implies congruent triangles. Now you can just write angle, angle, side if you want to. So now that we have the 2 triangles congruent, notice that segment AB, that's this blue one, and segment CD, that's the other blue one. Notice that AB are the first 2 vertices named in the first triangle, and CD are the first 2 vertices named in the second triangle. That means that segment AB corresponds to segment CD. So we can say that those 2 segments are congruent. Segment AB is congruent to segment CD, and that's a D, and the reason is CPCTC. Or if you prefer, if you want to say definition of congruent triangles, that's fine. That means exactly the same thing, okay? CPCTC stands for corresponding parts of congruent triangles are congruent. Okay, so we have flowchart number 2 completed. In flowchart number 3, notice that again, our proof statement is that we're going to get 2 parts congruent. We're going to get this angle M congruent to this angle P. So the way we'll do it is to show that M and P are, angle M and angle P are corresponding parts of congruent triangles. So let's see how we can get the 2 triangles congruent. Well, first of all, we are given that segment MN is congruent to segment NP. We're also given that MP bisects LO. Let me get a highlighter. I'm going to highlight LO yellow. So LO is being bisected. That means that this point, oops, I meant that to be a pen. Hold on. Okay, so this point N, that is a midpoint. And remember, when we have a midpoint, that gives us congruent segments. Also, I want you to notice that angles 1 and 2 are what we call vertical angles. And remember, we proved that vertical angles are always congruent. So we're going to get enough information to get the triangle on the left congruent to the triangle on the right. And then we can say that M is congruent to P by CPCTC. Okay, so let's start with our first piece of given information, that segment MN is congruent to segment PN. Okay, the reason for that, always put a reason below every box. The reason is given, so that gives us our first part. We were 1/3 of the way of getting the triangle on the left congruent to the triangle on the right. Okay, so now let's go to our second piece of given information, and let's watch this chain. We have a kind of a long chain here to follow. Let's start with the fact that we have segment MP bisecting segment LO. Okay, that's given information. Now, the definition of a segment bisector says that MP, oops, I meant that to be a pointer, just a second, says that segment MP, this segment MP, is a bisector if and only if it intersects the yellow segment at its midpoint, okay? So if we're going to assume that MP is a segment bisector, then we can say that N is the midpoint of segment LO, and the reason is definition of segment bisector. A segment or a line or a ray or a plane, any straight thing, is a segment bisector if and only if it intersects a segment at its midpoint. Okay, now What does the definition of midpoint say? Well, N is a midpoint if and only if it cuts this yellow segment into two congruent pieces. So I'm going to put 2 tick marks here and 2 tick marks here. So now that I have a midpoint, I can say that segment LN is congruent to segment ON, and my justification for that will be definition of segment, nope, sorry, we already used that one. It is definition of midpoint. A point is a midpoint if and only if it cuts a segment into two congruent segments. Okay, so I'm going to put another S. So now I'm 2/3 of the way of getting the triangle on the left congruent to the triangle on the right. Okay. Let's go ahead. As I look at the kind of the flow of this flow chart, I see these 3 arrows coming in here, and that's probably means that this is going to be the box where I say that 2 triangles are congruent. Okay, so let's go up here and get that. I have 2. I'm 2/3 of the way of getting the two triangles congruent. Let's use this box to use the fact that to state the fact that angle 1 is congruent to angle 2 because those are vertical angles. So I'm going to say, whoops, I'm going to do that in blue. Hold on just a second. Get the right color here. Okay, angle 1 is congruent to angle 2, and the reason is because of the vertical angles congruence theorem, which says angles are if 2 angles are vertical, then they are congruent. Okay, so that gives me an angle. All right, so now notice we have a side, and an angle. As long as this angle is the included angle, that's enough to guarantee that the 2 triangles are congruent. So if you look at one of the 2 triangles, I see 2 tick marks here. This angle 1 is the included angle. Remember, side angle is not a justification necessarily of 2 triangles congruent, but side always is. So I have enough. Do you see how now I have a side, and then we've got another side and an angle? That angle is the included angle. So now I have enough information to say the 2 triangles are congruent. So I'm going to call the triangle on the left triangle MLN. Okay, now we need to be careful when we finish this congruent statement. If I'm going to call the first one MLN, notice that's no tick marks followed by 2 tick marks. Then I need to call this one angle PON, or excuse me, triangle PON. So triangle PON. So the reason is side angle side implies congruent triangles. All right, now that the triangles are congruent, okay, look at our proof statement. We were to prove that angle P is congruent to, angle M is congruent to angle P. Well, notice that M is the first vertex named here. P is the first vertex named in the second triangle, so that means that they are corresponding parts of congruent triangles. So I can say that triangle, let's see what I was going to call it, M. Oh wait, we've already said that the triangles are congruent. So now that they are congruent, now I can say that angle M is congruent to angle P, and the reason for that is going to be CPCTC, which stands for corresponding parts of congruent triangles are congruent. If you want, you can write definition of congruent triangles. That's exactly the same thing. All right, so there's flowchart proof number 3. So now let's look at our last example, and this is an example where sometimes when a diagram has overlapping parts, it's a good idea to draw the parts separately. So in this proof, we have some given information, and what we're trying to prove is that segment EG is congruent to segment FD. So here's EG and here's FD. So what we're going to do is show that EG and FD are congruent because they are corresponding parts of congruent triangles. So what congruent triangles are we going to prove to be, or what triangles are we going to prove to be congruent? Well, the first one is this triangle, EDG. So I'm going to redraw that over here, and this is really important. Make sure that you label it. So this is triangle EDG, okay? And then the other triangle we're going to prove congruent is this one, FGD, okay? So I'm going to redraw it, okay? And I'm going to, again, label the parts. That's really important. So this is nuts. Sorry, I need to use the pen instead of the highlighter. Okay, this is FGD. Okay. All right, and then so we're going to prove that the yellow triangle is congruent to the blue triangle, and when we do, we'll see that EG and FD are corresponding parts of congruent triangles. Okay, so let's see how we can get those triangles congruent. Well, let's look at our first piece of given information, and that is that segment AD, this whole segment, is congruent to this whole segment. So what I'm going to do, these two segments, I'm not going to put tick marks because that's a little confusing. So I'm just going to put those brackets to show that those two segments are congruent. And the other thing I'm going to do is I'm going to outline this big triangle in red. Let's see if I can do that. Okay, so that red triangle is going to be an isosceles triangle, isn't it? If we're assuming, and let's go ahead and write this down, if we're assuming that segment AD is congruent to segment AG, that's given information, okay? Given that means that this red triangle is an isosceles triangle. A triangle is isosceles if and only if it has two congruent triangles. And one thing that we proved earlier this year is we proved that the base angles of an isosceles triangle are congruent. In other words, if these two sides of this red triangle are congruent, then the angles opposite those sides are congruent. Okay? So we're going to say that angle, let's see, I'm going to call the first base angle, I'm going to call it angle ADG, okay, is congruent to triangle AGD, excuse me, not triangle, angle AGD, okay, and the reason is because I'm going to write out the theorem in shorthand, because if two sides of a triangle are congruent, that implies that the opposite angles are congruent, okay? That is the isosceles triangle theorem, okay? Which says if two sides of a triangle are congruent, the angles opposite are congruent. Now, this is really important. In our separate diagrams, let's go ahead and mark that. So we have angle EDG has one tick mark, one arc on it. So let's put one arc right here. We also have that FGD has one arc, so let's put it on the separate diagram, okay? So that means we are 1/3 of the way. We've got a pair of angles congruent, so we're 1/3 of the way of getting the yellow triangle congruent to the blue triangle, okay? Now our second piece of given information says that this angle 1 is congruent to this angle 2. Now, angle 1 in the yellow triangle is angle E, so I'm going to put two arcs there. Angle 2 in the blue triangle is angle F, so put two arcs there. So that's good. That gives us another pair of parts congruent. So we are going to state our second piece of given information and say that angle 1 is congruent to angle 2. The reason that is true is because it's given information, so that's a second pair of angles congruent. Now to get the third pair congruent, I need you to look at the diagram where the two triangles are overlapping and notice that they share a side. This segment DG is congruent to itself. So I'm going to put one tick mark here, but then I'm also going to mark it on the separate diagrams. So a tick mark here and a tick mark here. So that's going to be enough, isn't it, to get the two triangles congruent. So we're going to say that segment DG is congruent to itself. And the reason is because of the reflexive property of congruence. Okay, so I'm going to put an S. So now, two angles and one side is always enough to guarantee that triangles are congruent. You just need to be careful and look at your diagram to determine whether the reason is going to be angle, angle, side, or angle, side, angle. We just happen to prove an angle, and then another angle, and then a side. But angle, angle, side may not be the reason. It could be angle, side, angle. So look at the diagram. Notice that this side with the tick mark is a non-included side, isn't it? There's only an arc on one end. The included side would be this one, wouldn't it? Because there's arcs on both ends. So this is a non-included side, so that means the reason that the triangles are congruent is going to be angle, angle, side. So I'm going to call the yellow triangle, let's call it triangle DEG. Now we need to be careful and name the blue triangle so that corresponding parts match up. So if I call the yellow one DEG, that's one arc, two arc, no arcs, then I need to call the blue one GFD, one arc, two arc, no arcs. So that's triangle GFD. The reason the two triangles are congruent is angle, angle, side. You can just say angle, angle, side if you want. If you want to say angle, angle, side implies congruent triangles, you're welcome to do that. Okay, so now that the two triangles are congruent, notice that we were trying to get EG congruent to FD, and the EG congruent to FD. If you look at the congruent statement, EG are the last two vertices named in the first triangle. FD are the last two vertices named in the second triangle. So that means that segment EG and segment FD are corresponding parts. And they're corresponding parts of congruent triangles. So we can say that segment EG is congruent to segment FD. And the reason is CPCTC. Okay, so there we have our last example. So you're going to work on some on your own, or work on some on your own. If you need any help, be sure and let me know.